Welcome to all. So in this session, we are going to discuss about the stick casting process. So in the previous videos, we have discussed about the field casting processes like sand casting um, and investment casting and all. So in this session, we are going to discuss only about stick casting. So we all know about what is casting. So casting is a primary manufacturing process through which we will get the products or the semi-finished products for other manufacturing processes like forging, rolling, and all. So in casting process, the raw material that is in the solid form will be melted, then it will be poured into the mold cavity. After it will be solidified, so finally you will get the product. So this is the process about casting. So here the word stir. So the stir casting. So in the casting process, after melting of the raw material, the stirring action will be induced to mix the molten metal properly. So the stir casting process is mainly used for for the fabrication of composite materials. So composite is another type of material where it will be formed or fabricated by mixing any of the two materials like metal, ceramic, or polymers. For example, if we mix metal and ceramic, we will get either metal matrix composite or ceramic matrix composite based on the proportion of the matrix and the reinforcement. So in composite materials, it is basically for getting a product which will have the advantage of both the matrix and reinforcements. For example, if we take the aluminum, okay, so aluminum is a very good material. Okay, it has low density, about 2.7 gram per cc, and it also has good corrosion resistance, good thermal conductivity. But the problem here is it doesn't have that much strength or that much hardness to resist the wear resistance or resist the low plastic deformation. So what we can do is, if we introduce the another phase, that is the secondary phase, that is the ceramic particles or fibers into the matrix material, then we can import the hardness and the wear resistance to the matrix materials. Thereby, we will get a new material which will have the advantage of both the materials. So ceramics will have high hardness and refractoriness, and it can withstand the high temperature, whereas the matrix material will be having good corrosion resistance and and ductility and low density. So the final product will have the advantage of both the material. The problem in composite material is if we mix the ceramic particles in the micron size or in the nano size, there is a problem that the matrix material will not properly uh, properly distributed, then we will get a deteriorated properties. So what we can do is, after the introduction of the reinforcement particles, if we stir it properly, then we will get the composite material with uniform distribution. So that is why we are going for the strip casting process. So this is the schematic diagram of the strip casting setup, where we have here we have this setup as a furnace. So inside the furnace we have a graphite crucible. So it is within the crucible only we will be melting the material, and we have a stirrer which is connected with the motor, and we also have the organ gas cylinder. So the organ gas is mainly used to make that environment inert. For example, if you melt the magnesium means the magnesium is highly reactive, so we cannot do the melting process in the atmosphere. So in order to make it inert or in order to make the environment safe, we use the organ gas, and also and also we have here a mold setup. So after melting and stirring process, then the molten metal will be the molten mixture will be transferred to the mold. The mold could be a squeeze casting mold or the vacuum casting mold or or it may be a centrifugal casting. So this stick casting is mainly for mixing the reinforcement properly to get the uniform distribution. Next, so how the process is being done. So this is what I'm going to explain here. So if you see the temperature and time diagram, so here we have the temperature in the y-axis and the time in the x-axis. For example, if we take aluminum, so if you take aluminum alone, so the pure aluminum has around 650 to 660 degrees Celsius as the melting point, and the aluminum alloy has less than 650 uh, degrees Celsius as the melting point. So in this process, what we do is we will heat the material above 700 or 800 degrees Celsius so that we get the homogeneous mixture of the molten material. So after that, while melting the aluminum, we also heat the reinforcement particles in the preheater. So the preheating is a very, very important thing. Before we cannot introduce the reinforcement particles as it is in the molten metals, since if we do so, then it may induce some defects like a porosity or a poor wettability and all. So in order to avoid all these things, we are preheating the reinforcement particles at 600 or 500 degrees Celsius so that if the reinforcement particle has particles have the moisture or some other dirt, means it will remove all these things, and also it will improve the wettability of the reinforcement particles so that we will get the composite with good binding between the reinforcement and the matrix material. So after heating to 810 degrees Celsius, for example, or 800 degrees Celsius, this molten material is hold, held at this temperature for a particular time. After that, the stirrer will be introduced. Okay, the stirring action will be done. So then, while doing this stirring action, the mixing of the introduction of the reinforcement particles is done in the crucible. So after the introduction, the stirring is continuous. So the stirring may be done at 300 RPM for 30 minutes or 40 minutes and all. So it's based on the type of material and how much reinforcement particles you are adding. So it depends on these parameters. So after that, this mixture is transferred into the mold. So as I said, the mold could be, it is based on your requirement. Some cases we go for a squeeze casting, and some cases we go for vacuum casting, or some cases we go for the centrifugal casting. It's based on the what type of final product we need, or it depends upon what type of matrix material we use. So after the transfer to the mold, it will be solidified. So we will allow the mixture to be solidified. So after that, we will get the final product. So this is all about the time, temperature, what are the processes involved in this stick casting process. Like other casting processes, the stick casting process also has some advantages and disadvantages. So first, let us see what are the advantages of stick casting process over other casting processes. The first one is cost effective. As you see, as we have seen in that setup, stick casting setup. So all the equipments what we have seen previous, all are not sophisticated equipments or are low cost equipment only. So it is a cost effective process. Then customization. So we can customize the setup for our requirement. Okay, so for example, if we want to have a stirrer with different size, or if we want to have the crucible at different size, or if we want to have the furnace with the different capacities, we can do that because all these things are very simple. The construction is very simple and it is cost effective. Then high quality material. So from this casting process, we can get the final product with good qualities, like the material can be a highly wear resistance or corrosion resistance, and it can be used under the extreme temperatures. The ease of use. So this particular process doesn't require the skilled operator, because The system is very simple, the construction is very simple, and the process is also very simple. It has very minimum number of processes, so anybody can do this without some precautionary measures. So these are the main advantages of stick testing process. And as I said, it also has some disadvantages or limitations like limited material selection. So we cannot use all type of material in this process. So there is some limitations like the selection of matrix and reinforcements. Like the biggest problem in composite materials, if you mix the two material with the extreme density difference, then there is a problem of settling down or agglomeration of the reinforcement particles. So before going for the material selection, we should be keep in mind that the important things that the density, the melting point, and all of these factors to be considered. Then limited structural integrity. So because of the inherent defects of casting, so this process also has all those defects, all those problems. Like we cannot get the product with superior qualities. Like product may be susceptible to the deformation and cracking under stresses. So then the limited scaling is another problem. Then the porosity. So in casting processes, in all the process we have porosity, but the same way this process also have some this porosity problem. So it is because of the entrapped air pockets. So it can be reduced by heating the mold, preheating the mold, or preheating the reinforcement particles and all. But so all these disadvantages or all these limitations can be we can control all these limitations or disadvantages up to a certain extent by following certain measures. Thank you.